Cool, just checking. All right, excellent. Hello, my name is Allissa Dillman, and I will be talking about my favorite thing, which is hackathons. I've now run, definitely over 50 of them in academia, industry, nonprofit, government. So it's definitely one of my favorite things to do. So I thought we'd start off with just making sure we're all on the same page with what a hackathon actually is. Now, I will say this model has changed a little bit over time, and in virtual settings, we've changed a little bit. But typically speaking, especially for live hackathons, it's somewhere between 2 and 4 day marathon. And the idea is to build tools to answer meaningful questions specifically with particularly interested communities. And this, at least for sort of these more bioinformatics types of focused hackathons, because I've definitely done with like artists and all sorts of stuff, but if you're talking about bioinformatics hackathons, usually the people we're focused on is scientists, coders, software engineers, educators, right? All the people that are either going to use the software, use research for the software, help build the software, like they're all going to come together with their disparate backgrounds and build things. And the reason for this being, obviously we want all that different expertise. We want it shared. We want to learn from each other, lots of peer-to-peer learning. We want to have lots of collaboration in different fields and different approaches. And we really want to have the whole point of a hackathon is it's meant to not be work as usual, right? We have a tendency in research to kind of be like, these are my collaborators. I'm going to see them every year at the conference. And these are like the group that I hang with, and we kind of cluster together. And the idea of a hackathon is like, these are people you don't normally meet, people you don't normally work with, and things you don't normally work on. So it's really kind of meant to be this very creative, not work as usual space. And I'm showing you this picture of this triangle because I really think that every hackathon, regardless of whether it's bioinformatics or art or somewhere in between, always has these three components. And that's the creation component, right? So what is it you're building? You're going to build something tangible. In bioinformatics, usually that's some sort of pipeline or software or something like that. Then you've got your collaboration point, right? Where you're going to be working with a lot of people you don't normally work with. But then you also have this education component, because first of all, you might be learning about some new piece of software or some new data, but you're also, again, working with peers that are not in your field of study. So you're learning from them. There's like tons and tons of peer-to-peer learning happening, right? Because maybe me as a biologist don't know the exact ins and outs of like the rules of software design and things like that, right? And the software engineer doesn't know the ins and outs and messiness of biology. So we're learning from each other. We also have different tools that can still be applied to similar questions, but you wouldn't know those tools existed if you weren't in that field of study. So there's a lot of things we learn. And I like to show it as a triangle because I do like to think of, well, every hackathon has all three of these components. You're definitely kind of weighting towards one of those three pillars a little more, right? Like, so in bioinformatics type hackathons, we do definitely tend towards that creation aspect. We're like, let's build a thing. For some groups I'm working with, they're really like, hey, we just need people to be interested. Let's collaborate. With other ones, they're like, people don't even know our stuff exists. We need to educate. So that's kind of like the three pieces that every hackathon has. Now, the beauty of the hackathon, besides the fact that you're actually working with people that you don't normally work with, is the idea that like at its heart, at its core, hackathons are about crowdsourcing. Now, this is sort of like the Wikipedia definition of it, and I'm going to kind of expand on that. So the idea is crowdsourcing is a method to obtain needed services, ideas, or content by soliciting volunteer contributions from a group of individuals, organizations, especially from an online community. That's kind of originally where this idea of crowdsourcing came in. But how we're using crowdsourcing here is really building community, asking, hey, what do you guys all want to do with this? What are you trying to accomplish? Where are your pain points? Where are the holes that you're trying to fill? And how can we work with you to build that thing together, right? Because what usually ends up happening is this idea of like, if you build it, they will come, right? If I just make a thing, I'll convince you all to come and you'll use the thing and everybody's happy. But this is not how we build sustainable communities and sustainable ecosystems and software and, all of these things. We need to work together, right? So first of all, if you actually have this crowdsourcing where people outside of your little bubble come in, they're bringing all of like their needs, right? The things that they want to do. Like you might think you understand all of those like nuanced needs, but like they're going to come at you with a whole bunch of other things, right? So in a hackathon, there's this idea of a project pitch where you're like, here's the overarching thing, but what do you want to do with it? So they give you all their ideas. Some of them are kind of like way over here because they're thinking about it in an aspect you never even thought of. Some of them you're like, okay, I kind of predicted those, but you're getting the whole breadth of the user base, right? Once you have that real deep and broad user-based interactions, then you can actually start to build use cases from sort of these different disparate communities and be like, oh, okay, actually, we had like these 3 use cases, but you bring a really good point in from, this particular community, or you bring a really good point in from this audience that you are working with. So, then you can actually build use cases that are from your users, not ones you make up when you discuss in all of your stakeholder meetings, right? These are actually like users telling you what they need. Then together, you're building community standards, right? Because now you're telling me what you need, I'm telling you how I can build, and we're now moving together to build those standards that everyone agrees upon, right? Again, it's not 5 people in a room deciding this is the standards we're going to use. So once you sort of have this community buy-in, they know that you want their input and you're trying to build things with them, you can form like true new collaborations, right? And you're getting ideas from outside that field. Once people are all together, they can actually then build the thing together. They can iterate on it together. They can produce completely novel software pieces that you never would have thought of, like those utilizations and things like that, right? They're also, because there's such a diverse audience, oftentimes you can now reach a broader audience with your software tool, right? Because they've now added things that you wouldn't have even thought of. So now that you've all produced something together, then you have a sense of ownership with the community, right? It's not just a software I built that I'm gonna make you use. It's a software we built together, and now we wanna use it together. We own it together. Once there's that ownership, right, then it starts getting sprinkled into education and all sorts of different things, and it starts popping up as like, yeah, this is a thing we built. We wanna use it. We wanna teach other people how to use it. We're really excited about using it. And then finally, that means you're also sharing resources, right? Because now I've built my training on it. Now, like, my lab is using it. Like, we definitely, like, we care about this thing and we want it to succeed. We're gonna like pool our resources, whether that's time or money or just ideas. And now it's something like we collectively own. So now that I've kind of talked about, like, this is why I'm so excited about hackathons and why they're super useful and important. I definitely have lots of different examples of how this actually ends up applying in real life, but obviously today we're talking about iCn3D. So I did want to have the final little part of this about, what I see, how this has worked in the context of iCn3D. So we've actually had numerous hackathons for iCn3D. The first one actually was here at ISMB in 2016. It was when they were in Orlando. And it was actually this really funky thing where it was actually a moonlight hackathon. So it was like the conference was going on during the day, and then people were like coming and hacking like during the evening. And that sort of like definitely proved that like this is something they can do in hackathons. And so quite a few hackathons happened both where I originally worked at NIH, so that would be NCBI, but also in data science office and things like that. So we did a couple of teams or even full hackathons. Like sometimes you want a hackathon where like the whole thing is about an overarching topic or software piece, and you want to kind of have each team running off in a disparate direction with different ideas to see kind of like, okay, what things stick, where do we want to go, which direction do we want to take, right? So you have that kind of move fast, break things, see which things work. And then sometimes you're like, okay, like there's a big hackathon and I just want one team because I have like this one thing I want to focus on and iterate on. So some of these hackathons, there's like the whole hackathon is about iCn3D, and sometimes they're just like one team in somebody else's hackathon even sometimes, which is the case for the CoFest, right? The CoFest happens here every year, usually after the conference, and it's not one that belongs to us, but like we can kind of inject a project and have people work on it in other people's hackathons too. So there's sort of been these overarching topics that have kind of come out of all of these different hackathons. So the analysis of biomolecular interactions and mutations, the analysis of biomolecular flexibility and symmetry, biomolecular representations of visualizations, analysis of large data sets, databases and annotations, adding to, there's always more annotations to add, right? Always more things to label and stuff like that. Then we've got things like collaborative interfaces and data sharing. So like I said, there's been a bunch of different projects. There's actually 19 different GitHub repositories, so different projects that have come out of these sort of larger overarching topics. And I did want to just highlight some actual like things that were built in a hackathon, or at least started in a hackathon, and ended up actually being part of the production level iCn3D. And actually, a couple of the different speakers have talked about these more in depth, so I'm glad I don't have to like spend any more time because I'm already probably done. But I did want to highlight, so the introduction of isoform and exon tracks in iCn3D the standardization of the IG data sets, the universal numbering system that Zhao talked about earlier, the auto-generating bridged ID of 1D maps. We had a SART to antibody interface analysis. And also, I think a couple of people have mentioned that there's this integration with Jupyter Notebooks as well. So hopefully I've gotten you really excited and raring to go. We're hopefully going to be doing a hackathon at NIH at some point, and then we're also planning to do one at ICMB next year's conference. Yes? Maybe. So stay tuned. Tell all your friends that hackathons are awesome, but also if you want to run more hackathons in general, let me know. I love talking about hackathons.
I imagine the online people can only hear me on the mic, so. Nice presentation. I think that did a really good job talking about how hackathons work, especially with iCn3D. I think one question that I have for you is, if someone was really hesitant or unconfident in their technical skills or their time, what would you tell them about hackathons to make them feel a bit more comfortable in participating?
Sure, yeah. So I actually have a GitHub repository that is a collection of a whole bunch of free asynchronous training materials around bioinformatics, around R, around Python, even free computing resource materials if you need it. So that's one great place to start. But there's also plenty of asynchronous materials to kind of like get you feeling a little more confident. But the other thing is, for a lot of the hackathons we run, we actually build the teams, and we're very mindful about how we build them, making sure that there is different expertise levels on each team. So it's not like all the expert coders are on one team and like biologists, forget it, you're on another team. Like, we actually make sure each team has a well balance of, expertise and skill levels. So we welcome beginners always.
All right, great. Thank you.
Thank you.